Hello everybody, myself Jyoti and today this is part 17 of Legends of the Physics World. Only one person has ever won two Nobel Prizes in physics, but unless you happen to be a physicist yourself, chances are you have never heard of him. Contrary to the usual stereotypes, he was neither an egomaniac nor a torture genius. A loving husband and father, he was a gracious man with a sweetness of spirit who loved to play golf with his buddies on the weekends. Yes, I'm talking about John Bardeen. He was born on 23rd May 1908 and died on 30th January 1991. So, about him, he was an American engineer and physicist. He is the only person to be awarded the Nobel Prize in Physics twice. First in 1956 with William Shockley and Walter Brattain for the invention of the transistor, and again in 1972 with Leon Cooper and John Robert Schrieffer for a fundamental theory of conventional superconductivity, known as the BCS theory. Bardeen, Cooper, Schrieffer. That initials have taken. Before transistors, we used to use vacuum tubes. So what was the problem with the vacuum tubes? Vacuum tubes made the first radios and televisions possible. On the other hand, they consumed a lot of power, needed time to warm up, and tended to get very hot. To develop smaller and more effective amplifiers, however, it was hoped that semiconductors could be used. In 1947, John Bardeen and Walter Brattain produced a semiconductor amplifier, which was further developed by William Shockley, and the component was named a transistor. Transistors are such an integral part of our lives today that we barely notice them. They gave us pocket-sized transistor radios in the 1950s, then portable televisions, video cassette recorders, and compact disc players. They were exceptionally versatile. Besides amplifying electricity, they could switch it on or off. We know the switching characteristic of transistor. That made them ideal as the basis for a second generation of computers. Digital computers whose binary logic of true and false, 1 and 0 could be encoded by the on and off states of transistors. About superconductivity, we know that when certain metals are cooled to extremely low temperatures, they become superconductors. That means they carry the current without any resistance. So, conducting electrical current entirely without resistance based on quantum mechanics, John Bardeen, Leon Cooper, and Robert Schrieffer formulated a theory for the phenomenon in 1957. At extremely low temperatures, the interaction between electrons and atoms in the metal's crystalline structure causes the electron to pair up with one another, and that pair it is called as Cooper pair. As a result, their movement becomes orderly, unlike the random movement at normal temperatures, and electrical resistance disappears. Every luminary of 20th century physics had taken a crack at explaining superconductivity, from Albert Einstein to Werner Heisenberg to Richard Feynman, but none had solved it. Bardeen did, along with two younger colleagues. Today, superconductivity technology is used in the world's most sensitive detectors of magnetic fields, with applications ranging from oil prospecting to medical imaging. So, we use superconductivity in MRI imaging and so on. So, as a human being, John Bardeen died in 1991. Some of his neighbors never knew he had invented transistors and explained superconductivity, or that he was the only person in history to win two Nobel Prizes in physics. They remembered him as a modest, unassuming man who liked to grill hamburgers for the neighborhood and who would always ask his guests if they wanted the bun toasted, which was how he liked it. So he was a very simple man. He said, the combined results of several people working together is often much more effective than could be that of an individual scientist working alone. So, we should all, when we are doing some kind of research, we should all collaborate, all people, all the expertise should come together, and let's take science forward. Thank you so much.